Okay, let's talk a little bit about net force. And so that's just determining the total force on an object. First, we'll just look at without an angle. So suppose that you had an object, that's not a good pen. Suppose you had an object that was experiencing, say, 3 forces. Or we'll just do 4, just because. All right, so let's say this is, let's say 10 newtons. This could be 12 newtons, 8 newtons, and let's do 5 newtons. All right, so the idea is you just add them. They just need to be in the same coordinate system or coordinate direction. So we would define like x and y to be in this direction. So what I want to do is I want to get the net force in the x direction. Then I'm going to look at anything that goes left and right. So that would be this one and this one. So let's label these things. Let's call this force 1, force 2. So the net force would be simply force 1 plus force 2. And then if I put in the values, you just have to indicate the direction by using the sign. So F1 would be 12, positive 12, plus F2. F2 though is is going to the left, so it's plus negative 5. And so we get a, what is that, 7 newtons to the right. So that's the total force in this direction, in the x direction. Going up and down, the net force in the y direction would be, let's call this F3, and this would be F4. So it'd be F3 plus F4, and likewise, just depending on the direction, we put in the sign. F3 is 10 newtons, but it's up, so it's positive. Plus F4, which is down, so it's negative. So plus negative 8. So we get 2 Newton force, and that would be up since it's positive, like this one was right since it was positive. So the sign indicates the direction. So sign is direction. And it just depends on the way that we define our axis. So that's no angles. So what happens if we have an angle? Because now it's not just going to be in the xy. Move this down a little bit. So now suppose that you have a force being applied at an angle. Call that F1 and say that's 12 newtons. And you have another force coming straight down, similar like weight, and this would be F2. We'll make that 5 newtons. So then the question is, what's the net force in the x and y? Well, the net force in the x is going to be a component here. So again, we do x and y like so. So I can see that it appears that there's nothing acting in the x, but you have to remember that this force here can be broken into 2 parts, into these components. So let me change this over to red. And so what we get is we get force 1 in the x direction, and then force 1 in the y direction. So there's force 1 in the x, and force 1 in the y. And then we would have some angle here. Let's say it's like 10 degrees. Okay, so fix those. So my net force in the x direction, if I look here, it's just going to be this single force, F1 in the x. So that would be F1 in the x direction. And now you just have to use some trig. Since it's next to the angle, that's going to be the magnitude F1 times next to is cosine. Cosine of 10 degrees. And then we would just substitute 12 times cosine 10. That would be my force, my net force in the x direction. But how about in the y direction? So the net force in the y direction would be, well, F1 in the y, and it's going up, so it'd be F1 in the y direction plus F2, because F2 is also in the y direction. F1 in the y, since it's opposite, that's going to be F1 sine 10 degrees. And then F2 is down, so it's going to be -5, so plus -5. And then we would just calculate that. F1 is 12, and we just plug it in, and that tells us what our values are. All right, so, it's just using a little bit of trig, knowing, opposite is sine, next to it is cosine. And then we always multiply that by the magnitude of the hypotenuse. Okay, last example. Let's look at an inclined plane. All right, so suppose we had an inclined plane and there was a crate sitting on it. All right, so we're gonna have some angle, let's say 10 degrees. And now let's draw our forces. So we know that there's a force of gravity acting down, or weight. And now we need a normal force. Now, so remember that the normal is perpendicular. So the normal actually comes up like so. It's going to be perpendicular to the plane. Okay? Now this is where it gets tricky. With an inclined plane, we actually want to tilt the x and y axes so that the x-axis is straight down the ramp and the y is perpendicular. That means that the normal is in the y direction. And then we need some piece of gravity that's going to be acting in the x. But just like we did up here, what we're going to do is we're just going to break it into two components, my x and y. So I would have one that would come down here. That would be my force of gravity in the y, and then my force of gravity in the x. So this is Fg in the x. Sorry, I drew this poorly. That's Fg in the x direction. So this piece right here is actually what's pushing it down the ramp, or trying to push it down the ramp. You see how this aligns with this? And so if you always draw this, this just reminds you of how to draw these components. That's where most mistakes are made. And then the angle is always up here at the top. So this is 10 degrees. And then this would be Fg in the y direction. All right, so now we can start solving it. So my net force in the x direction is going to be anything that's in the x, up and down the ramp. And it looks like it's just that one, my Fg in the x direction. And then Fg in the x direction, it's opposite the angle. So it's going to be the magnitude, Fg, times sine 10 degrees. Because that was my angle here. Now, in the x, I could have had, I might have had some friction acting on this. And if I did, then the friction would be coming off in this direction. So I could have some kinetic friction. So then I would just subtract it off on this side. I could do minus F, kinetic friction, like so. But that's only if there's friction. All right, let's do the y direction. So the net force in the y direction. So now I'm looking in the y direction. So it's going to be the normal force plus the force of gravity in the y direction, but it's subtracting. So it's going to be negative Fg in the y direction. And we could simplify that. Fg in the y, that's next to it, so it's cosine. So it's going to be the normal minus Fg. It's next to, so it's cosine 10. But here's the thing, it's all going to be 0. Anyway, we'll get to equilibrium and stuff, but it's more practice just figuring this stuff out, setting up the diagram really. So anyway, there's your 3 examples. You'll have some practice and then you'll take a quick assessment on it. Not too bad, if you need some more practice, I can always give that to you.